All right, today for 4.4 in Algebra 2, we're doing determinants and Cramer's rule, so still on our matrices. Okay, so today our objectives are to find the determinants of a 2x2 and 3x3 matrices. We're going to solve a system of equations using Cramer's rule. And the last part here, find the area of a triangle using a determinant. It is more of an advanced skill here, so we may and may not get to that. Actually, I don't even think I gave you all the notes for it. It's on my notes, but not yours. So we probably will not get to that last part, or I might just show it to you, but you may not have it on your notes, so don't worry about it if you don't. All right, so first of all, a determinant of a 2x2 matrix. Determinant means, okay, it is the difference of the products of the major and minor diagonals. Okay, so there's a few things there we're going to look at with that in mind, language-wise. So first of all, we have here, this is DET as determinant of A, matrix A, which is a 2x2. And this is the symbol for determinant. Notice it looks like the absolute value of A. That is what the determinant symbol is. So we're going to find the determinant of matrix A, which is ABCD. It says it's the difference, which is subtraction, so you'll notice the subtraction right here, of the products is multiplication, of the major and minor diagonals. Okay, so I'm going to take A times D, and that goes here. That's your major diagonal. And it's the difference, so we're going to subtract the product of the minor diagonals. So right here is C times B, and that part goes there. Okay, so I find the products of the diagonals and I subtract them. And I have to do the major minus the minor, okay, is the deal there. So even if you want to write that out, we're going to take the major diagonal and subtract the minor diagonal product from it. So let's look at example 1. We want to find the determinant, because it's got these absolute value symbols instead of the brackets, of 3, 5, and 2, 4. So we're going to find the product of our major one, 3 times 4, okay, which is 12. We're going to find the product of our minor diagonal, so we're going to do 2 times 5, which is 10. And then I'm going to find the difference between these. Okay, but the thing is, I have to do 12 minus 10 because this was the major diagonal. So 12 minus 10 equals 2. All right, so the determinant here is 2. That is all there is to it for the determinant of a 2x2. So let me clear this and let's get to the determinant of a 3x3. Or, yeah. Okay, I can get all that to fit in there. So the determinant of a 3x3 matrix. To do this, we're going to rewrite the first 2 columns to the right of the matrix. That may seem a little weird, but I'll explain it to you as we go. So we've got our 3x3 matrix, A, B, C, D, E, F, G, H, I. In order to find the determinant here, because we need to multiply the diagonals, right, we have to take these first 2 rows and rewrite them. So we're taking the first 2 rows and we're rewriting them in 2 columns to the right of the matrix. Okay, so we're just rewriting them first of all. And the reason we do that is so we can next find the sum of the products. So we're going to sum, this time, the products of each set of diagonals. So we're going to do our major diagonals here. So we have AEI. So AEI plus, because it's the sum, of our next diagonal, which is BFG, which we see here, plus our next major diagonal, which is CDH, right here. So we add those together, and we get that's our major diagonal then. Okay, for our minor diagonal, we're going to start at the bottom just like we did, and we're going to multiply up, and we have GEC, that's our first number, plus HFA, which is what we see next, and then we add our last one, and our last one is IDB. And and that's our minor diagonal. Okay, so when we actually do these out, you'll see me overlap them a little bit, right? Because you don't have to rewrite them separately. Like you could say, okay, here's this one, and there's our third. But it is a 3 by 3, so notice you're going to have 3 numbers down here you're going to add together, and 3 numbers, I will write them at the top in the future, but 3 numbers for the minor that you add together. Now then, the determinant is the difference still, just like we did on the 2 by 2, of the major and minor diagonals. So I'm going to take the sum I get from my major diagonal, AEI plus BFG plus CDH, and I'm going to subtract the sum that I got for the minor diagonal, and that will give me my determinant. It's always the major minus the minor diagonal to get the determinant. Okay, so down here with our determinant of a 3 by 3 matrix, we've kind of got the same terminology. We've got determinant of matrix A, which is a 3 by 3. We have that same symbolism for the determinant of matrix A. We've got these and the formula written out, just like we showed up here where it all came from, right? So this is the major diagonal, the sum of all 3 major diagonals, and this is the sum of the minor diagonals, and we're still finding the difference or subtracting those to get the determinant. Okay, so that's how we find a determinant of a 3 by 3 matrix. All right, so let's clear this and go on to the next one to actually give it a try. All right, example 2, you're going to see it says find the determinants. A is done for you there a little bit. Well, actually all of it, not just a little. And so we're going to look at it and then we'll do B. Okay, so for our major determinant, or to find the determinants. So we've got our matrix here. We take these first 2 columns and we rewrote them to the side. That's why we have 2, 1, 5, 3, 7, 2 here. Okay, then we're ready to multiply our major diagonals. So 2 times 3 times 6, 2 times 3 times 6 is our first one. 1 times 4 times 7, 1 times 4 times 7 is our second one. 3 times 5 times 2 is the third part. So if we go back and do the math, we have 36 plus 28 plus 30, and that equals 94 for this major determinant here. For our minor determinant, we're going to start at the bottom and work our way up. 7 times 3 times 3, okay, which is right here. And then we're going to do the next one, 2 times 4 times 2. So we're going to add that in there. And our third diagonal across there, 6 times 5 times 1. And we add those all up. So 7 times 3 times 3 is 63. 2 times 4 times 2 is 16. 6 times 5 times 1 is 30. So that minor determinant is 109. So this number is 109. Our last step is to subtract. So we take the major determinant, the one that we start at the top and we go to the bottom. This is why I like to write my numbers down below and up above. Okay, so 94 is my major determinant. I'm going to subtract my minor determinant. So yes, I'm going to have a negative number. So my answer is negative 15. The determinant here is negative 15. All right, so let's try this with B. Okay, so our first step is to rewrite the first 2 columns. So I'm not going to copy everything down here. I'm just going to go here. So I've got 9, 8, 6, 5, 3, 2. Okay, so let's start our major determinants. 9 times 5 times 1, I'm going to write as 45. I'm not going to write 9 times 5 times 1. I'm going to go ahead and write it out. 8 times 4 is 32. 32 times 3 should be 96. I'm grabbing the calculator so I can check my math. 8 times 4 times 3, right? 96, look at that, okay. I screw up sometimes on the fly, especially. All right, so 96, and then we have 7 times 6 times 2, right? 7 times 6 times 2 is 42 times 2. So we have 84. All right, so now I'm going to add up these three numbers, 45 plus 96 plus 84, and I get 225 for my major diagonal. Okay, so now I'm ready for my minors. So 3 times 5 times 7. So 3 times 5 is 15. So 105 plus 2. I believe that's 2 times 4. It's so hard to see sometimes on my board. Yeah, 2 times 4. All right. Sorry about that. So 2 times 4 times 9. 2 times 4 is 8. 8 times 9 is 72. Plus, and our last one is 1 times 6 times 8. So 1 times 6 is 6. 6 times 8 is 48. So now I'm going to add those up. 105 plus 72 plus 48 equals 225 for my minor diagonal. Then my last step, remember, is subtracting them. It's the major minus the minor. In this case, it doesn't really matter, but I want to make sure you remember, like, get it ingrained in your brain. Major minus minor. So my answer here is 0. Okay, the determinant to this matrix is 0. Okay, now the cool part about this is we can solve a system of equations using determinants. And that's what we're going to do next. So let me move it on up here. Oh, yeah. Sorry, I was going to go back for a second, but I'm like, no, I did everything. Okay, so next up, a system of equations can be solved using determinants. So if we look at this system, we've got 5x minus 3y equals 9, and x plus 4y equals 11. Again, always check that your x's are lined up, your y's are lined up, your constants are in order, because we can rewrite this as a matrix with that a times x equals c that we've talked about. All right, so we've got our coefficients from our variables, 5, -3, 1, and 4. Our variables in order, right, x and y, we bring them and park them in that x column. And then it equals our constants, 9 and 11. Now, this one's tricky, or it says next, create 2 more matrices, a sub x and a sub y, by replacing the coefficients of each variable with the constants. Okay, so notice here in a sub x, okay, we replaced the constants, okay, so the constant columns, the 9 and 11, we replaced those with that first column where the x's were. Okay, so we put them in, so like when we wrote them out, 9 was the coefficient, 5 was the coefficient for our x, and -3 was the coefficient for y. Now we're putting the 9 in for this first column and the 11 in as well. Okay, now when we do a sub y, our matrix a sub y, we leave the values we had in that first column. And like I said, I kind of say that this is the x and the y sometimes. And we replace the y column with the constants, the 9 and the 11. You're probably like, what? This is crazy. And it kind of is. But we're going to make it work. Okay, so in doing this, okay, so we've got all these matrices here. Let me erase this here for a minute. Okay, and go back here. So we have matrix A as well. Matrix A is 5, -3, 1, and 4, right? And this is just A. So what we need to do, or how we can find the values of x and y, can be found using determinants. Okay, so we're going to go here. What it's saying is I can take, to find x, I'm going to take the determinant of a sub x and divide it by the determinant of a. And to find y, I can take the determinant of a sub y, divide it by the determinant of a. But that means we have to find all of these components. But remember, it's a 2 by 2. So, or these are 2 by 2, so it's a little bit easier to see. To find the determinant of a, which is right here, determinant of a, right? We're going to take our major diagonal, the product of our major diagonal, 5 times 4, so 20, and our minor diagonal, 1 times negative 3 is negative 3, and we subtract them. So 20 minus negative 3 is the same thing as plus. That's how we got 23 here. We do the same thing for each of these. Our a sub x, 9 times 4 is 36. And that's what we've got. 11 times negative 3 is negative 33. And then you subtract those. 36 minus negative 33. That's the same thing as 36 plus 33. That's how we got 69 for the determinant of a sub x. And a sub y. 5 times 11. Well, that's 55. Our minor diagonal, 1 times 9 is 9. 55 minus 9 gives me 46. So there are my determinants for a sub x, and a sub y. Now I just take these values and I plug them into these formulas. So to solve for x, we're going to take the determinant of a sub x, which is 69. We're going to put it in the numerator. We need the determinant of a in the denominator. The determinant of a was 23. 69 divided by 23 is 3. To solve for y, we're going to take the determinant of a sub y, which is right here. We got 46. 46 goes in my numerator. Divide by the determinant of a, okay, which was 23. So we put it in the denominator. 46 divided by 23 is 2. So our solution to the system is 3, 2. We did not have to use substitution. We did not have to use elimination. None of those things. We were able to use it just by finding the determinant of the matrix. And I know it takes more time to start with probably than you might feel like than just solving the system would take. But as you get more familiar, you'll get faster. All right, then we have a black box for some unknown reason. There it is, got rid of it. Next up, we have this thing called Cramer's rule, okay? So Cramer's rule is a system of equations represented by the matrix equation AX equals C that has the unique solution, okay, where? So we have the solution x, which is the determinant of a sub x divided by the determinant of a, and y, which is the determinant of a sub y divided by the determinant of a. And this keeps going, right? If we had z, if we had q, it'd be the same thing. It'd be the determinant of q divided by the determinant of a, or a sub q divided by the determinant of a. Like, however. So Cramer's rule says a system of equations represented by the matrix equation AX equals C has a unique solution, X and Y, where A is the coefficient matrix and the determinant of A is not 0. A sub X is the matrix formed by replacing the coefficients of X in matrix A with the constant matrix. We just talked about that up above. Okay, A sub Y is the matrix formed by replacing the coefficients of y in matrix A with the constant matrix, and so on. If you have matrix Z, if you have matrix, or if you have, another matrix with a Z in it, if you have an X, a Y, and a Z in there. If your determinant of the matrix equals 0, the system does not have a unique solution. Okay, that's important. If your determinant of A equals 0, it does not have a unique solution. Okay, so you are finished with that. Okay, so let's look at example 3, and we're going to solve it using Cramer's rule. So it says, the steps there, it says create matrices A sub X, and A sub Y. Okay, I have done that for us to speed it along a little bit. Okay, so we've pulled out matrix A from our equation, right? 4 and 3 and 6 and negative 1 here. Okay, so if I did maybe I should have said, like, looked at the A, X equals C. So if I did that, I would have A, right? My X column would be, well, let's just start over. Maybe it would be good for you to see that. So we would have 4, 3, 6, -1. Then we have XY equals, and our constant matrix is 8, 1. Okay, so we wanted to find the determinant of A, right? The determinant of A. We're going to take our major diagonal here. I don't like using that highlighter, sorry. So let me erase it after all. All right, so we're going to take 4 times -1. So we've got 4. 6 times 3 is 18. So we're going to have 4 minus 18. 4 minus 18 equal, hold on. Oh, it was -4, pardon me. -4 minus 18 equals -22. That's our determinant of A. Now, A sub x. Remember, I took A and I replaced the x values with my constants. That's why I have 8 and 1 here now. So 8 times -1 is 8, -8, pardon me. And 1 times 3 is 3. So the determinant of A sub x is going to equal -8 minus 3, which is -11. And our last one, okay, A sub y, we've replaced our y values with the constants 8 and 1. Okay, so we're going to have 4 times 1 is 4, and 6 times 8 is 48. Okay, so that's going to leave us our determinant of A sub y is 4 minus 48, which is -44. Okay, so the part that's not on here is we're solving it. So to find x, remember x equals the determinant of A sub x divided by the determinant of A. Well, A sub x is -11 divided by the determinant of A, -22. So this equals 1/2 for x. All right, for y equals the determinant of A sub y divided by the determinant of A. A sub y is -44. The determinant of A, -22. So this is a +2. So the solution to this set is negative, or it's 1/2. I'm going to have to write it up here, comma, 2. That is the solution to this system. Okay, that's the solution to this system. All right, so let's do B. We're going to do it all from the beginning. So let's actually start with this AX equals C equation. So we've got our X's lined up, our Y's lined up, and our constants. So we're in good shape. So we've got 3, -8, 7, 4 times X comma Y equals our constants, which are 58 and 22. All right, so now we need determinant of A. So that's going to be 3, -8, 7, 4, if I will write it correctly. Okay, so then we're going to have 3 times 4 is 12, minus 7 times -8 is -56. All right. Right. Okay, so 12 minus, which is the same thing as plus 56, equals 68. So that's determinant of A. Let's do the determinant of A sub x. All right, so in A sub x, we're going to have We're replacing our x values, right? So this first one, the x column is going to be the constants, the 58 and the 22. And then I'm going to keep my y column, -8 and 4. Okay, then we do our major diagonal. So 58 times 4 equals 232 minus, and our minor diagonal, 22 times -8 equals what? Good, -176. And then I need to subtract those. All right, so 232 minus -176, which is the same thing as plus, gives me how much? Perfect, 408. All right, one more here. Do the determinant of a sub y. Whoop, I don't want that line. All right, so this time we keep the first column, the 3 and the 7, and we replace the second column, that y column, with our constants, the 58 and the 22. All right, so start with your major diagonal. 3 times 22 is 66. Very nice. Our minor diagonal is 7 times 58. What does that equal? Good, so it's minus 406. All right, so we've got 66 minus 406 equals -340. All right, so we're ready to move on to solving for x and y. Okay, so x is going to equal your a sub x, 408, divided by the determinant of a, 68. So what's 408 divided by 68? Excellent, that equals 6. All right, and how about our y? So y is going to be our a sub y, the determinant of a sub y, which is -340, divided by the determinant of a, which is 68. So what is -340 divided by 68 equal? Perfect, -5. So what is the solution to this system? Excellent, it is 6, -5. That is the solution. Okay, sorry, I had to pause for a minute and figure out what was going on. All right, example 4 is doing the same thing, right? We're going to solve using Cramer's rule, except that you'll notice this time we have 3 variables. We have an x, a y, and a z. Okay, so it is going to make us, we're going to solve using Cramer's rule, but this time it's a 3 by 3. Okay, so first of all, let's do our ax equals c equation. All right, so for our first equation, we have 1, 2y, -z, so -1. Our second equation is 1, -4, and a +1. And for our third equation, had to erase that and make it a little longer here. We've got 2x, a 2 for y, and just a z, so a 1. Okay, our x matrix is going to be x, y, z. And our C matrix is -1, 2, and 6. All right. So because this is a 3 by 3, it is going to require us a little bit more work, but because we have to find the determinant of A. Okay, we're going to find the determinant of A, the determinant of A sub x, the determinant of A sub y, and a determinant for A sub z. Okay, so let's start with the determinant of A. Because it's a 3 by 3, remember we copy down these first 3. So I've got 1, 2, -1, 1, 2, -1, 1, -4, 1. What am I? My brain isn't working, I guess. It's always a good sign, right, from your math teacher. 2, 2, and 1. Okay, then remember we have to rewrite those first two columns. So 1, 2, 1, -4, and 2, 2. Okay, and that's so we can work our determinants. So, or work our diagonals. So we've got 1 times -4 times 1 is -4, plus 2 times 1 times 2 is 4, plus -1 times 1 times -2 is going to be -2. So -4 plus 4 is 0, plus -2 is -2 here. All right, then we're going to do our minor diagonals. 2 times -4 is -8, times -1 is a +8. 2 times 1 is 2, times 1 is 2. So we're adding. 1 times 1 is 1, times 2 is 2. So 8 plus 2 is 10, plus 2 is 12. Remember, to find the determinant, we subtract these. So we take the major, -2, minus 12, we get -14 here. Okay, then we need the determinant of a sub x. Okay, when we find the determinant of a sub x, recall that that is when we put our constants in for our x values, that x column. So we're going to have -1, 2, and 6. And then we're going to copy down the other two columns. So 2, -1, -4, 1, 2, and 1. And then remember, the next thing, since it's a 3 by 3, is we copy down the first two columns to the right. I should have given myself some more room, so I'm going to erase here so I have it. So I'm going to have -1, 2, 2, -4, and 6, 2. All right, then we're ready to start solving our diagonals. So we have -1 times -4 is +4, times 1 is +4. 2 times 1 is 2, times 6 is 12. Remember, we're adding down here. And -1 times 2 is -2. -2 times 2 is -4. So 4, again, I'm going to move around. 4 plus -4 here is 0, so this one's just going to give me 12. Let's do our minor diagonals. 6 times -4 is -24, times 1 is +24. 2 times 1 is 2, times -1 is -2, so we're adding -2. And 1 times 2 is 2, times 2 is 4. So 24 plus -2 is, wait a minute, I feel like I have something wrong here. 4 plus 12 is 12. Okay. Oh, maybe not. Okay. 24 plus -2 is 22, plus 4 is 26. And then we subtract the major, 12, minus the minor. So 12 minus 26 is -14. I've got a lot of numbers circled up here. Maybe I shouldn't circle so many of them. So we have two that are -14. Okay, I'm going to have to move over here to find my determinant of a sub y. Okay, so in this one, we're replacing the y column with our constants. Okay, so I'm going to write this column first, 1, 1, 2. I'm going to replace my y column with -1, 2, and 6, because those are my constants. And then I'm going to copy down my z column, -1, net 1, and 1. Then I copy my first two columns to the right. So 1, -1, 1, 2, and 2, 6. Okay, major diagonals first. 1 times 2 times 1 is 2. -1 times 1 times 2 is plus -2. Plus -1 times 1 times 6 is -6. 2 plus -2 is 0. Plus -6 is -6. Minor diagonals. 2 times 2 times -1 is -4. 6 times 1 is plus a +6. And then plus again. 1 times 1 times -1 is -1. -4 plus 6 is 2, plus -1 is -1. And then we subtract the negative 6 minus negative 1. Hold on, did I get negative 1? No, that's a positive 1, isn't it? My bad. Yeah, that's a positive 1. So negative 6 minus 1 equals negative 7. And I still need an a sub z in there, the determinant of a sub z. So hopefully you understand this. I'm just going to tell you about a sub z, maybe if that works. Because I'm running out of a room here. So the determinant for a sub z equals, and yes, I know I get to take the shortcut, equals negative 42. All right. So I do get to take the shortcut. That's kind of handy. I'm sorry about that, but we're going to save you some time and get through it. So to find x, right? X equals the determinant of a sub x divided by the determinant of a, which is the determinant of a was negative, or a sub x is negative 14 divided by negative 14, so x equals 1. Y is the determinant of a sub y, which we said was negative 7, divided by the determinant of a, which is negative 14. So this equals a positive 1/2. And z is going to equal the determinant of a sub z, negative 42, divided by the determinant of a, which is negative 14. Okay, so negative 42 divided by negative 14 is a 3. So the solution to this set is x, 1, y, 1/2, z, 3. That is the solution to this system. Okay, so it's a system with 3 variables or 3 equations, and we can solve it using Cramer's rule, matrices, determinants, all those things. Okay, all right, so I will see you tomorrow, and we'll get started on this and see how it goes.